So we will start our second unit today. Our second unit basically contains the basic counting principles. So in that, the first one is principle of mathematical induction. So principle of mathematical induction basically contains two steps. We can say the first step is called as basic step and the second step is called as induction step. So whatever proposition or expression we are having, if that is true for the value 1, then it will be true for n plus 1 and then it will be true for all the values of n. That is nothing but roughly principle of mathematical induction is. So suppose let P be a proposition which is defined on the integer. The condition is n should be greater than or equal to 1 such that first condition is P of 1 is true, means whatever value we are having on that proposition, we will put the value as 1. So if we will get the same value, then your P of 1 is true. If P of 1 is true, then P of n plus 1 is true whenever P of n is true. This is very necessary and mandatory to learn that whatever proposition we are having, if that is true for P of 1, then it will be definitely true for P of n plus 1. But if our proposition does not satisfy P of 1, then definitely it won't satisfy P of n plus 1 at any condition. So that is nothing but principle of mathematical induction, that whatever proposition we are having, if that is true for P of 1 means n is equal to 1, then it will be true for n plus 1 and then P is true for every integer, like where n is greater than 1. That is what principle of mathematical induction is. Now we will see how. Suppose we are having this particular example where the problem will be asked as solve by principle of mathematical induction. Principle of mathematical induction. And this is the particular example, that is P of n, that is nothing but proposition, is equal to 1 plus 3 plus 5 plus 2n minus 1 is equal to n square. So we will go with step 1. So what we have to do in step 1? This. We have to find out that it is true for 1 or not. So in this we will put the value of n is equal to 1. Okay, this is our step 1, which is basic step, or we can say this is basic step for induction. So we will say that 1 plus 3 plus 5 plus 2n minus 1 is equal to n square. Now we will put the value of n is equal to 1. So 2 into value of n is 1 minus 1 is equal to n square, that is 1 square. So this is 2 minus 1 is equal to 1, that is 1 is equal to 1. Now as your LHS is equal to RHS, this P of 1 is true. That means your step 1 is true. As your step 1 is true, you will go for your step 2. So in step 2, keep in mind, whenever your proposition is true for n is equal to 1, you have to put the next value, that is n plus 1. So what is our proposition? That is 1 plus 3 plus 5 plus 2n minus 1 is equal to n square. Now we will put n plus 1 value in that. So what is value of n plus 1? So we will put as 1 plus 3 plus 5 2n minus 1 plus 2n is equal to n square plus 2 P of n plus 1 is true when n is greater than 1. This is how we used to solve the example by principle of mathematical induction. First we have put the value of 1. We have received the same value, that's why it is true for P of 1. Then we have put the value plus, that is n plus 1 value. After that we are focusing on RHS. We are getting n plus 1 square, means your proposition is true for n square. That's why your proposition is true for n plus 1 square. So P of n plus 1 is true whenever n is greater than or equal to 1. So in this way we can solve the example of principle of mathematical induction.